So what is a quadratic? The quadratic formula helps us find the x's or the x. So anytime you have x equal, what I want you to think is that when I graph that equation, that is where that line that the equation made will cross the x-intercept or the x-axis. Sorry, will cross the x-axis. So x equals means that's my x-intercept. An x-intercept is also called a zero. And sorry, they're also called roots. So there are three interchangeable names for them, but I just wanted to, with the first two slides, explain what we're doing when it says find x. Okay, so a quadratic equation is an equation or a function that has a variable raised to the power of 2. Okay, there's only one unknown. The unknown is usually called x, but it could be t. So there's one unknown, but one of the unknowns is squared. So x is squared, t is squared. Good. So it contains a square term as well as linear terms. Square terms, when you graph them, make shapes like this. Linear, just think line, makes a line like this or like this. So x is linear, 3 is linear, because if I just said x equals 3, it would look like this. If I said y equals 3, it would look like that, right? So these two terms are linear. This one is a square term. This is 2x squared plus x equals 3 is a quadratic equation in x. 7t equals 5t squared plus 1 is a quadratic equation in t. It just means the variable we named it t, here the variable we named it x. There is a formula for finding the value of the unknown. The first, all this is saying is that we need to write it in the form ax squared plus bx plus c equals 0. So that is not in that form right now. That's 2x squared plus x equals 3. If we were going to put it in that form, we would move the 3 over, right? So we would subtract 3, and it would be 2x squared plus x minus 3 is 0, right? And we call it ax squared plus bx plus c because we are going to take those terms, a, b, and c, or whatever that number is, 2, 1, and -3 in that case, 2, 1, and -3. And we're going to substitute them into the quadratic formula. Do you see that b, there's the a, and there's the c, okay? So when you say c, ax squared plus bx plus c equals 0, they're just showing you a quadratic equation. We substitute in whatever values are in front of the x squared, the x, and whatever the constant is. So in this case, a is 2, b is, there's nothing in front of the x, right? But there is one x. And the c is -3. Make sure you take the sign in front of it. So that's a +1, +2, -3. Again, we are finding the roots of the quadratic equation. So they're also called the x-intercepts or the zeros. I'm going to show you, darn it, I wish this was black, but what's done is done, right? Okay. What we have here are 3 planes, right? Coordinate planes. A quadratic function is graphically represented by a parabola. I think I already drew that up there, right? With a vertex located either at the origin. Okay, that is a vertex located at the origin. The vertex is the top of the or the bottom of the parabola. That's the vertex. Good. So if the vertex is located at the origin, the place it's going to cross the x-axis is at x equals 0. So my answer, if my parabola has a vertex at the origin, my answer for that quadratic equation is x equals 0. Okay. 1 second. We also have below the x-axis. Remember that a parabola can be opening up or opening down. Below the x-axis would look something like this, right? And then we have two places where that graph is going. This is not in my math lab. I just want you to make sure you understand what we're looking for. So you could, oh my goodness, you could just put that into Desmos and find out where they cross, and that's your answer. All right, anyway. This is one of my x-intercepts, right? -2, and maybe that's number 3. So it's below, the vertex is below the x-axis. So it's going to cross the x-axis at -2 and at 3. So two of my answers are x equals -2 and x equals 3. Good. And then there's one more situation where it could be above the x-axis. In this case, sorry about that. Okay, and then when it's above the x-axis, it's never crosses. So there are no roots, no zeros, no solution. Good. Those are the 3 ways that the parabola might exist. Or, it could be opening down like that, or it could be opening down like that. But basically, it is possible to have no solutions on the x-axis. It's possible to have 2 solutions, or it's possible to have 1 solution. 1, 2, or 0 roots. Roots are x-intercepts, or roots are what x is equal to. That's all to say what we're doing here. So you are perfectly welcome to take your quadratic equation. You're perfectly welcome to factor it to find the answer if that's possible. And you're also perfectly welcome to put it into Desmos and see if it's easy to see what the 2 or 1 x-intercepts are. Okay. This quadratic formula is for when you can't really use that. Okay. A quadratic equation has the solutions, or x values, x equals -b plus or minus the square root of b squared minus 4ac over 2a. Why is that? That is because if you took this original equation and you solved it for x and did all of those steps, what you would end up with is x equals this. Okay. So that's what they did. They did it for us. We don't have to do it. We can not do it. And what this means right here is that there are 2 possible answers, right? So x is -b plus the square root of b squared minus 4 times a times c over 2a, and x is equal to -b plus the square root of b squared minus 4 times a times c over 2a. Good. All right. So let's solve this. This is all we're learning today. Just make sure you also feel comfortable with using it and the imaginary numbers from Monday. So the equation is 2x squared plus x equals 3. Let's solve it using the quadratic formula. If you put it into standard form, if you rearrange it so that all terms are on one side and you see that it is factorable, go ahead and factor it. Okay, you don't have to use the quadratic formula. It is just one option. So how to do it? Let's number these. Oh my gosh. My pen's broken. Oh, I'm so angry. Okay, 1, 2, 3, 4, and 5. There are 5 steps. So first you want to look at your equation. It's an equation because it has an equal sign. Look at your equation. Rearrange the equation so that all terms are on one side. 2x squared plus x equals 3. We already did it once on the first slide. So we're just going to subtract 3. What we get is 2x squared plus x minus 3 equals 0. Good. All terms are on the left. It doesn't matter if it's the left or the right, okay? Next step is write down the values of A, B, and C. A is 2, B is 1, C is -3. Good. Now, step 4 says, step 3 says, substitute the values into the formula. So our formula is x equals -b plus or minus the square root of b squared minus 4ac over 2a. Good. So we're just going to substitute, leave x. -b means a -1 plus or minus the square root of 1 squared minus 4 times 2 times -3. Good. All right, that was, oops, not even finished. Over 2 times the number 2, because a is a 2. I took that, I substituted in 2 for any a's, 1 for any b, and -3 for the c. All right, step 4. It just says work out the values in the under the square root and in the denominator. So -1 plus or minus. What's this going to be? 1 squared is just 1. 1 minus 4 times 2 times -3. Don't be shy about using your calculator. Don't, you want to finish this class. You don't want to make a mistake that costs you your credit. So we have 1 minus 20. No, 1 plus 24, right? Because I have -4 times 2 times 3, so that is 1 times -3, so 1 plus 24. The -4 times the -3 become positive. That positive times 2 is still a positive. So we have 1 plus 24, that becomes 25. Good. And then 2 times 2 is just the number 4. So that was step 4, work out the values in the square root and the denominator. Now, now that we've done that, almost, -1 plus or minus, make sure you can't simplify this at all, okay? So can you take what is under the radical, now that it's only one term, and turn it into a simplified radical? The square root of 25 is 5. Lovely. So we have 1 plus or minus 5 over 4. That's step 4. Step 5 now asks us to split the formula into 2 using plus in one of the formulas and minus in the other formula. So we have -1 plus 5 over 4 is equal to x. And then we have -1 minus 5 over 4 is equal to x, right? So let's solve each of these. -1 plus 5 is 4 over 4. -1 minus 5 is -6 over 4, right? We know that 4 divided by 4 is 1 because those are two terms that if you have the same at the top and the bottom, they cancel each other, right? So essentially the 4 is canceling the 4, but we don't call that 0. We just call it 1, right? 1 over 1, which is 1. -6 over 4, you can put it in your calculator, but what I think is easiest or most helpful when you have a fraction and you want to simplify it is take 6 and put it into its factored form. So if I have 6, what does 6 become? 6 becomes 3 and 2, right? 3 times 2 is 6. So -6 is -3 times 2. 4 is just 2 times 2, right? And then I want you to cancel on the top and the bottom. And what we are left with is -3 halves for -6/4. Okay, you can divide 6 by 2 and you get 3. You can divide 4 by 2 and you get 2. My answers are x is 1 and x is -3 halves. Again, it's perfectly fine if you use factoring instead of the quadratic formula. Now, on the exam, definitely, especially, make sure you can plug that into your original equation, and the equation is still true. So 2 times 1 squared plus 1 is 3. Perfect, right? I just did this half, it equaled 3. 2 times negative 3, oops, halves. I never know if that or that is erase. Erase versus delete. Anyway, 2 times negative 3 halves squared plus negative 3 halves. Also 3. So those both work out. Those are my x values. You're just going to do this over and over again. All right. Solve 3n squared plus n minus 3 equals 0 using the quadratic formula. So that first step said it equal to 0, right? Move it all to one side. We have already done that. The next step asks us to find the values of a, b, and c. In this case, a is 3, b is 1, c is negative 3. Because it's a minus 3, that's a plus n, so there's 1 n. That's a 3. That's very close to the other one, right? The other one was 2, 1, negative 3. Okay. Again, this is the same as 3x squared plus x minus 3 equals 0. It's just n, exactly the same. Okay, does not matter. The third step was substitute, right? So now we're going to substitute into x equals negative b plus or minus the square root of b squared minus 4ac over 2a. I realize it sounds really far away. I've been doing that lately. Good. So let's look. We have b is 1. So we have negative 1 plus or minus the square root of 1 squared minus 4 times a positive 3 times a negative 3 over 2 times 3. Is that okay? Oh, yes, go slower. Would love to go slower. Thank you for asking. All right, so my advice is if you use a note card, put this on your note card. This is just the same as those equations we were doing for factoring, right? So you can try to think about what would multiply to equal negative 9 and what would add to equal 1. Yes, don't worry if you have to leave, there is a video. Good, so this is the exact same thing we're doing. We're just finding x values. Just like we found x values by factoring, we're finding x values this way instead, okay? So if you can't find it by factoring, you can use the quadratic formula. Now, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a, always. It never changes. The important thing to remember is that this makes it 2 different equations most of the time. Good? All right. So we have substituted in our variables. Now it asks us to solve. Remember, it was solve what is under here and solve what is under here. So that's negative 1. 1 squared is just 1, right? Minus, or instead of saying minus and then multiplying 4 times 3 times negative 3, I like to just look at it as, like I did last time, negative 4 times positive 3 times negative 3. So that's a positive 36. So I'm going to say it's 1 plus 36 over, over 2 times 3 is just 6. Good. I'm going to simplify. X equals negative 1 plus or minus the square root of 37 over 6. Good. Step 5 is split the formula into 2 using plus in one and minus in the other. You want to make sure you've looked at that square root of 37 and you can't make it any simpler, right? When we did the square root of 25, we changed it to 5. So make sure that 37 isn't anything that you can simplify, which it is not. Okay, 37. The way I like to do it is just divide it by perfect squares. 5 times 5 is 25. 4 times 4 is 16. 3 times 3 is 9. And then 2 times 2 is 4. If I can't divide it by any of those, it's not, you can't, that means I can't simplify it any further because it has to be, you have to be able to take out a perfect square, right? Okay, so we're going to now split it based on that plus and that minus. So we have -1 plus the square root of 37 over 6 and -1 minus the square root of 37 over 6. Those are both equal to x. Of course, thank you for letting me know. Good. Those are your answers. You can't take it any further. You can't take 1 divided by 6 and change it into anything simpler. We can't make square root of 37 anything simpler. We're done. That's a fine thing to write. We're not gonna put it in our calculator and get a decimal and put the decimal instead. You're just gonna put something like that. Good. All right. Let's do these 3 examples. Oh, good. We're starting right away with an imaginary. That's good because I'm getting behind. Not going slow enough, but also getting behind. Dang it. All right. So we have x. No, what I need to do is, I know what I need to do. I need to straight away put this on a different piece of paper. X squared minus 6x plus 12 equals 0. That 6 looks like a B. All right, so the first thing we do is we make sure that it's in standard form or set equal to 0, and that we have our x squared first, the x second, and the constant is third. What you want to do now is tell me what A, B, and C are, and that's the second step, right? So it's A sub 2. A is equal to 1. There's 1x squared, which is pretty common when A is 1, right? We've seen it a lot when we were factoring. B is, it looks like a B, but it's a -6. And then C is +12. Good. Part 3 asks us to put A, B, and C into -b plus or minus the square root of b squared minus 4 times A times C over 2 times A. Good. -b, -6. Don't leave out either of the negatives or leave them both out and make it a positive, but only because you know to do that, not because there was a mistake. So -b becomes negative, but b is already negative, so -6 plus or minus the square root of -6. When you're putting that in your calculator, remember, I feel like it's a long time ago when we were doing this. The square root of -6 with parentheses and the square root of -6 without parentheses will give you a different answer. Okay. Make sure we're taking this, we're taking the square of -6, so use parentheses. Minus 4 times, A was just 1 and C is 12. Divided by 2 times 1. Good. All right. Step 4 asks that, so that was just substituting. Step 4 asks us to simplify everything under here and under here. I'll simplify this too. -6 becomes a +6. We already did it. -6 squared is 36. Now I'm going to take -4 and I'm going to multiply it by 1 and by 12. -48. So 36 minus 48. Negative times a positive is going to give us a negative answer. Just make sure that makes sense in your brain. Okay, the calculator told me that, and I believe it because that's two positives and a negative. All right, 36 minus 48. So we can simplify 36 minus 48 as negative 12. Good. Okay, this is on the exam. In a situation where we haven't covered imaginary numbers, you could say no solution, right? Because the square root of negative 12 is not real. But because of what we did on Monday, we know that the negative 12 under the radical becomes, and we need to do exactly what we did on Monday, okay? The square root of negative 12 becomes the square root of negative 1 times positive 12. Good. Which becomes, remember, the negative 1 under the radical is just the letter I. If you missed Monday and that's a lot of information, don't worry. If you do watch the video, it makes sense. So 12, the square root of 12 is still the square root of 12, but I think we can simplify. Let me just write it again. Good. So now we have I squared of 12. 6 plus or minus I square root of positive 12. But I think we can simplify the square root of 12. So we're going to keep I. 12 becomes whatever you want, right? You could say two of the factors of 12 are 4 and 3, right? You could say 6 and 2, or you could say 4 and 3. 4 is a perfect square, or 4 becomes 2 times 2. 3 remains 3. Those two can come out. So now that's 2 square root of 3. And you can make sure that that's true. Okay. So we, first of all, we made a negative under the radical into an imaginary number. That's the imaginary number. Then we took it a step further. We simplified that because it's now positive. So the square root of 12 becomes 2 square root of 3, but we need to bring down that I. Right? I times 2 times square root of 3, rewrite it as 2I square root 3. Good. The square root of negative 12 becomes 2I square root of 3. Back to x equals positive 6 plus or minus 2I square root of 3 over 2. Okay. Now, something else that's very important to do with fractions is we want to, before we separate it into 2 for the x and the y, or sorry, for the positive and the negative, we want to look at the fraction itself. So think about 6 divided by 2. Okay. And then separately, think about 2I square root 3 over 2. Okay. And now we have two different fractions that we can simplify. Just like we simplified negative 6 over 4 becomes negative 3 over 2, right? 6 halves plus or minus 2I squared of 3 over 2, 6. Let's factor 6 becomes 3 times 2. Oh, this is the same one, right? And then 2 just remains 2. What do you see on the top and the bottom that both can cancel? Here I can cancel 2 over 2. Here I can cancel the 2 and the 2. So this becomes 3, just like 6 divided by 2 is 3. And then here, I square root of 3. because we canceled the 2's here, just like we canceled the 2's here. They're common to both the top and the bottom. Now separate it out. We're just going to say x is 3 plus I square root of 3. X is 3 minus I square root of 3. So that is the most work you're going to have to do in my math lab. If you're comfortable with that, you don't need to, I mean, make sure you're comfortable with that. And if you are, yeah, congratulations, you are ready for the homework. Good. And if you have questions about that, about how I got each part, feel free to let me know. I know we don't have much time, I apologize. All right, B is x squared minus 5x plus 6 is 0. Good. What is A? A is 1, B is -5, C is 6. We're going to put it into x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b is going to be a -5 plus or minus the square root of -5 squared minus 4 times 1 times 6 over 2 times 1. X is -5 becomes a +5, so we're just simplifying for step 4, plus or minus -5 squared. Don't be shy to use the calculator. 25. 4 times 1 times, oops, sorry, -4 is -24 over 2 times 1 is 2, right? One step simpler, 5 plus or minus 25 minus 24. Wonderful. That's the square root of 1 over 2. Always make sure it's not a perfect square. Oh, it is. So the square root of 1 is just 1. So that becomes x equals 5 plus or minus 1 over 2. Now we're going to split it into positive and negative. So we have 5 plus 1 over 2 and 5 minus 1 over 2. Okay, let's talk about this again. 5 plus 1 is 6 over 2. Not done yet. 6 becomes 3 times 2. Cancel the 2's. X is 3. 5 minus 1 is 4 over 2. 4 is 2 times 2. X is 2 and X is 3. Good. When you think about it, X is 2 and X is 3, that means that when we factored x squared minus 5x plus 6, we said we want it to multiply to equal 6, add to equal -5. Right? And what numbers would I get? I would get a -3 and a -2, right? They multiply to equal a +6 and they add to equal a -5. X minus 3, X minus 2. If I factored it, set them both equal to 0. X minus 3 is 0, X is 3, X minus 2 is 0, X is 2. So this is exactly the same answer you're going to get if you had factored instead of using the quadratic formula. Just a different way to find the same x's. I wonder if we have time for letter C or no? Yeah, let's do it. All right, letter C. Is 2x squared plus 3x minus 2 equals 0. So A is 2, B is 3, and C is -2. Good. X is -3 plus or minus the square root of +3 squared minus 4 times 2 times -2 divided by 2 times 2. -3 plus or minus 3 squared is 9. -4 times 2 times -2. -4 times 2 times -2. 16. Positive, so I'm going to say 9 plus 16 over 4. -3 plus or minus 16 and 9. 25 over 4. -3 plus or minus the square root of 25 we know is 5 over 4. Then we're going to separate it into x equals -3 plus 5 over 4 and x equals -3 minus 5 over 4. Good. -3 plus 5 is what? 2? Because 5 minus 3 is 2. 2 over 4. Again, put it into the prime factorization. 4 is 2 times 2. Don't say it's 0 over 2. Say it's 1 over 2, right? And then here we have -8 over 4. The factorization of 8 is -4 times 2. And here we just have 4, right? Or you could say 2 times 2 times 2. And 4 is 2 times 2. And in that case, either way, you get a -2, and there's nothing on the bottom, so it's 1, right? So here it's x is 1/2 and x is -2 as our answers. If you plug them back into here, you should get all of that equals 0. 2 times -2 squared plus 3 times -2 minus 2 is, and hopefully your calculator says 0. Then you'll do it again as 2 times +1/2 squared plus 3 times +1/2 minus 2. And hopefully your calculator gives you 0. No parentheses right there. Nothing to, yep, no parentheses. All right, I think that's enough. Oh, it's not. It's not enough to finish the homework. We need to do right, maybe it is. Yeah, no, sorry, that was me. That was Monday. All right, that's enough. So I don't think you need to watch the other video, or the video to see the last 3 examples, but you can. And if you have questions, come on Friday. On Friday, I'm just going to do the exam study guide, but there will be a video of the exam study guide too. So if I don't see you, bye. I hope you have a great Christmas break. Email me if you need anything, and I will see some of you Friday.